Hello and welcome to the quadratic formula. I have it written here, and it is, of course, a way to solve quadratic equations. Now, when I mean solve, I'm talking about taking a graph. Let me make this a little bit smaller, and I just want to show you what I mean by solve. All all second degree polynomials are all quadratic equations. I'm air quoting that. Will make these things called parabolas. And where it crosses the x-axis are known as the solutions. So the solutions. And what we're in the business of here is finding these x-axis intercepts. And the way that you do that, there's several ways that you can solve it. You can factor it and solve it that way. But if you can't factor it, let me just make one real fast. Let's say I had x squared minus 2x plus 1. Okay, and I was doing something like that. Well, I could factor this into two binomials, x, minus 1, and minus 1, and that's equal to 0. And so I could figure out what makes these parentheses equal to 0, and that would be, of course, 1. Because if I plug a 1 in for this x, actually since they're the same, it would only have one solution, which I'll get to in a minute here. But this solution to this would be 1. So it would cross this graph here, would hit the x-axis at 1. So this would be an example where this thing comes down and hits right there and literally like bounces off the x-axis. It would have one solution. Now, how do you determine how many solutions it has? That's the whole point of this today. And it is called the discriminant, discriminant. And the discriminant is b squared minus 4ac. It's what's underneath this radical sign. So if I solve for this discriminant on this example problem here, well, what I like to do, let's just do this example here. If I have, I'll rewrite it, x squared minus 2x plus 1 equals 0, and I list the variables a, b, and c, a would be 1, okay, because that's a 1 there. B would be negative 2, and c would be 1. Now, if I plug in a, b, and c into this discriminant here, this is called the discriminant, it will equal a certain answer. So let's do it. This would be negative 2 squared, make sure you put that in parentheses, minus 4 times 1 times 1, which would be 4 minus, what is 4 times 1 times 1? Well, that's 4. So 4 minus 4 is 0. So this is a great example of what happens, and I didn't really mean for it to happen, but it kind of accidentally happened here, so that's why I'm talking about it, where the discriminant equals 0. If the discriminant equals 0, then you have one solution. It's rare that this happens, but it does happen. So the little cheat sheet I want to make for you and talk about and show you what the graphs look like, I'll tell you what, we probably should put this on a separate graph, is if I have b squared, or separate layer rather, b squared minus 4ac, we'll write this 3 times, and I'll make a little chart out of this, like so. Okay. Make it look like that right there. First one's crooked, isn't it? Let me fix that. You noticed that too, didn't you? We can't have that. Okay, perfect. So if this answer is positive, you have two solutions. And the graph, I'm just going to sketch a quick graph. The graph will look something, I'll tell you what, it could actually look two different ways. it could look like this, having two solutions here and here, or it could look upside down like this. A parabola can open down like that, but you would have two solutions. So that's the first and most common example. If it equals 0, so if it equals 0, like in the other example, we have two possible graph looks. It could come down and bounce off the x-axis, hitting the x-axis once, or it could come over, say like that, and open down and bounce off the x-axis, having one solution. The other example, which I'll put in a dramatic purple here, is it's negative. So if you get a negative answer, you're going to have, imaginary numbers in your solution, but the graph will have no real solution. It'll have no real number solution, and I mean real number. Okay, so it will have an imaginary solution, but it will not have a real number solution. So what do those graphs look like? Well, it would be like it doesn't hit the x-axis. So you could have a parabola, say, up here, or a parabola that is down here. But regardless, the solutions to a quadratic formula are answers where it hits the x-axis. So this would be an example of where it would have no real solution. And that's how you're going to use the discriminant in a quadratic formula problem to understand that. And that's really all I have for this video. We'll be back for more later to do examples. See ya.